Sir, you park the right hand around and look for the corner. I'm a man that where you stand, go right to your bar.
So today we're going to look at an activity series of Metal Lab in which we're going to develop an activity series rather than look at one and use it. And it should match the handout you have. So what you'll see in a minute is that the trays have been set up to match. And what we're really interested in is, did a reaction happen or not? This is a purely qualitative lab. So down the left side are the 5 metals: copper, magnesium, lead, zinc, and silver. And across the top, you'll see that we've got aqueous solutions. So this is copper nitrate, magnesium nitrate, lead nitrate, etc. And all we really need is a yes/no. You don't even have to really put observations. It's, did a reaction happen or not? And a reaction happening would be anything you see that indicates that. It'll be primarily color changes. So if you take a look here, here are our solutions. The copper nitrate is blue, and so if this undergoes a color change, a reaction will be obvious. The other solutions are colorless, so we're going to have to look at the metal. And here are the metals.
If you stay still, I
Okay.
can zoom in. Okay.
So we've got copper, magnesium, lead, zinc, and silvers here. And you notice there's blank squares because it doesn't really make any sense to react copper nitrate with copper. So on the chart, those are already X'd out for you. So what we're going to do now is we're just going to add some of each solution and then come back and look. You can put
Right.
Okay, so now we're ready to see where we had reactions. And remember, what we want is, did a reaction happen or not? So there's going to be either a yes or a no in every box. So let's take a look at the copper metal. If you look, still shiny copper, still shiny copper, still shiny copper. No reaction for these 3. But if you look in this one, it looks very much like your copper-colored pellet has been completely covered with a silver-looking metal. There's a reaction. And what you'll end up doing is putting a yes in that box. And then, for this one, you'll write the balanced equation. And if you're in honors, you'll write a net ionic equation for it. Okay? So copper reacted once. So I'm going to write a 1 for copper metal. Okay. I'm not going to go through every one of these, but let's look at the magnesium metal. It reacted every time. You can see, and if you look at the copper one, you can see we've actually had a pretty dramatic color change. So magnesium's getting a 4. So if you take a look, you can then see how many times the silver metal reacted, the zinc metal, and the lead, and we should get a 0, a 3, and a 2 out of these, and then we'll be able to rank these metals from most to least reactive. And that'll be the first piece of building the activity series. And I think one of the first questions on the lab is arrange these from most to least reactive. And then what your job will be eventually is, for each one that reacted, you write a balanced equation. If no reaction happened, you don't have to write anything. You don't have to do descriptions. So the metals will always be solids. The solutions will always be aqueous. And in the next section, we're going to look at some other metals so we can see if we can expand our activity series. Now we're going to work on part 2 of the activity series lab. if you look on your lab handout, most of the spots have already been filled in. Some of the reactions aren't safe to do here, and some of them are simply no reaction, and you don't need to see too many of those. So first we're going to do 3 reactions with hydrochloric acid: aluminum, zinc, and magnesium. And what we're looking for is a comparison. So everything in this lab is qualitative. So I'm going to take a piece of aluminum out, drop it in the hydrochloric acid, and if you take a look, I'll hold it up.
Oh, I got it.
Oh,
I think I got it anyway.
You see that there's no reaction. Okay. If you take a look on the periodic table, aluminum's over there, toward the right-hand side and a little bit up on the table. Now we're going to go to zinc. If you look on the table, zinc's a little further to the left, a little bit lower down. Okay, take a piece of zinc. The exact size obviously doesn't matter. Drop it in the acid, and you see a small stream of bubbles coming off. The bubbles indicate we're making a gas. It's a single replacement reaction. You can figure out the 2 products. Third in acid, magnesium metal. Magnesium all the way over to the left on the table. Let's take the piece of magnesium, drop it in the acid, and much more vigorous, energetic reaction. If I put my hand on the outside, it's a little bit warm, indicating it's exothermic. And remember, what you're trying to do here is a general comparison of the reactivity of the aluminum, the zinc, and the magnesium. Now we're going to go to several reactions where things react with water. Okay? If you look in the lab handout, many of them are filled in. The only one we're going to do with hot water is calcium. We're going to do calcium metal with cold water and with, it's actually warm water. To give us a little bit of a hint of what's going on, I'm going to put a drop of phenolphthalein into just one of these. Phenolphtalein an acid-base indicator, and it will turn pink if we raise the pH above about 8.5. And that'll mean we're making hydroxide ions. So take a little piece of calcium, drop it in, and you'll see a stream of bubbles coming up. And you might also notice a faint pink color beginning to form. We'll give it a little more time. The pink color is actually on top of the metal where the bubbles are forming. Oops.
I'm trying to give these guys motion sickness because I can't keep the camera straight. There we go.
I think you can see a little bit of that pink color. So we're making some hydroxide ions. This is also a single replacement reaction. The bubbles tell us we're making a gas. I'm going to do the same reaction in the hot water, just as it'll help with the comparison when you want to analyze it. The reaction is the same. And not surprisingly, it's a little bit more energetic reaction because the water molecules, being warmer, have more energy. So we get a faster reaction. Sodium in water. Here's our sodium. It's stored under mineral oil, as you can see. The sodium is given to us pre-cut. So here's a piece of sodium. You can see on the inside, it's got a shininess.
Just zoom in on this.
And it was actually much shinier a minute ago, but it's already reacted with the oxygen in the air. I'm going to put this in the water. And we'll try, remember, we want to compare this to the lithium, and we want to compare this to magnesium, which was done on your chart.
Okay, ready?
Ready? Here we go.
race around.
And you can see that's much more energetic.
Ooh. Now it's hiding.
Stuck at the side. Let's help it out. Probably even hear the bubbles forming.
I definitely think you can.
Let's let it all react.
Okay.
And there's sodium. So I think we can say the sodium reacted more enthusiastically than the lithium. Last one coming up. Not good tweezers. It's so slippery, of course. Get another pair.
Okay.
Okay, we going?
Yeah.
Oh, potassium in water. Potassium also comes pre-cut. Here's a little piece of potassium. And let me get all these guys out of the way. Drop it in the water and see what happens.
Ooh, that's exciting.
So the reaction's over, and you might have noticed that reaction was so energetic and exothermic that it actually ignited the gas that it was produced. And if you think about some earlier labs you've done, you may be able to think about what gas is flammable. The purple flame comes about because we actually energize some potassium atoms, and when you do a flame test lab later in the year, that'll show up again. You don't have to memorize stuff like that. So here's our calcium in water after a few minutes, and you can see we've got the pink color, which indicates we've made a fairly sizable amount of hydroxide ion in this single replacement reaction.